So in this video, we are going to continue our discussions of chapter number 3, coordinate geometry. So we're going to understand the concept of coordinate planes in this video. So first, let us try to revise our concept of number line. What exactly is a number line? So I'm going to quickly draw a number line. We have seen this before multiple times. Okay. So this is a typical number line. And if you want to represent integers on the number line, then at the center you have your 0. So I'm going to mark it 0, and then this is your 1. Okay, sorry, and this is 2, and this is 3, and so on. And on the left hand side you have negative numbers, so -1, -2, -3, and so on. So you can see on a number line, okay, if you give any point on this number line, okay, on this number line, then you can find the distance of that point from the origin. So first of all, let us call this 0, which is like the center of the number line, as origin. Okay, so if I give a point here, let's call this point as P. If I give some point here, let's call it Q, or if I use some point here, let's call it R. Okay, we know very precisely and very accurately what is the distance of these points P, Q, R from the origin 0. Okay, so for example, if we zoom in a bit, okay, so we can see that P is like in the middle of 1 and 2. So we can say P is at a distance of 1.5, okay, from the origin. This is our origin 0. Then let's go to Q. Q is also in the center of 2 and 3. So the distance of Q from the origin is like 2.5. Okay. Now let's focus on R. So R is on the left hand side of the origin. So it's on the negative side. It's also in the middle of 1 and 2. So its distance will be like -1.5. Okay. The sign minus indicates this direction, either it's on the left hand side or the right hand side. The distance from 0 is obviously 1.5, but the negative sign is very important to indicate whether our point lies on the left hand side or the right hand side of the origin. Now conversely, if I say locate, okay, locate point, okay, locate point X at distance, okay, at a distance -2.5, okay, from the origin, then how will we do it? Okay, so we saw that if a point is given to us, we can figure out the distance. Now we are doing the converse operation. Someone has given us the distance of a point and we have to locate it on the number line. So since it is a distance of -2.5, so minus means it's on the left hand side, and -2.5 will roughly come here. So at the middle of this, middle of 2 and 3. So this is our point X. Similarly, we can take another point, let's say Y, which is at the distance of, let's say 1, distance of 1 from the origin. Okay, Y is at a distance of 1 from the origin. Now once again, since it's +1, we know it's on the right hand side of the origin. So this is our origin and 1 from the origin. So right hand side is going to come here. So our point Y is going to be exactly here from the origin. So this is how you can see that how a number line, this is a number line, we are using the number line to locate different points on the number line. However, now the usability of this number line is very limited. What if there is a point on this plane? Okay, let's use, yeah, so or I'll use different color. Yes. So what if there's a point somewhere here, okay, or there's a point somewhere here, or there's a point somewhere here. So what if there are points which are away from the number line, which are not on the number line? Can we find out their positions, okay, their coordinates using the number line? So apparently it seems yes, we can definitely do that. And the way to do it is exactly, we are going to use two number lines which are perpendicular to each other. Okay, now how are we going to do it? Let's see. So first of all, this is our number line which usually we draw horizontally. So I'm going to quickly make it 0, and this is like 1, this is 2, this is 3, and this is -1, and this is -2, and this is -3. Okay, this is typically how we represent a number line. Now what if we draw another number line which is perpendicular to or let's say vertical in direction. So this is our another number line, and the markings will be same. So in the center we'll have 0. So here we'll have 1 and 2 and 3, and below we'll have -1 and -2 and -3. Okay, so both of them are number lines. Okay, but they are in different directions. One is in a horizontal direction and one is in the vertical direction. Now what we are going to do is something interesting. We are going to put these two number lines over each other. Okay, how are we going to put it over to each other? In a way that they are perpendicular to each other. So this word is very important. So these two number lines, we are going to overlap over each other such that they are perpendicular to each other. Before we do that, let's name this number line. So let's call this as x dash and x. Okay, it's a line basically. So x dash and x, and let's call this as y and y dash. Okay, now let us overlap these lines on each other such that they are perpendicular to each other, and the 0 and the 0 of these lines intersect with each other. So I'm going to use highlighter again. So this 0 and this 0, they should intersect with each other. So let's see how we can do it. So what I'm going to do is I'm actually going to take this line, okay, and move it. So I'm going to move it like this, and this is how these two zeros are going to intersect with each other. Yes, okay, and thus we have got, okay, there is a small problem. Okay, let's do one thing. Okay, let's bring this down here a bit. Okay, and let's bring this one on it. Okay, so that exactly now they are again overlapping with each other. Okay, and thus we have got two number lines which are perpendicular to each other. This is our actual horizontal one and this is the vertical one. And now we have this whole system which is actually called as a Cartesian system. So there are certain terms now which are associated with this system, which is what we are going to see. But before we see the terms, let us erase this. Okay, erase this highlighted part. Yes. Now, what are the terms which are related to this arrangement of two number lines perpendicular to each other? So the terms are written here. What I am going to do is, let's take them to this side. Yes. Okay. So first term is called origin. So this point where both the zeros intersect with each other is called as origin. Quite simple. Okay. So I'm just going to mark a tick mark. Now the next term is positive x-axis. So as you can see, let's move it a bit here. Yeah. So this is our x-axis, x dash and x-axis. So this is the positive part of the x-axis because it consists of positive numbers, and this is the negative part of the x-axis because it contains negative numbers. Quite simple and straightforward. So let me in fact note it down. Let's use different color. Yeah. So this is our positive x-axis. So I'm going to write it positive. Okay. Yeah. So this is our positive x-axis. Positive x-axis. Okay, done. What is negative axis? This side. It's called negative x-axis. So these are some simple and basic terms which are related, which we will be using to referring different points on this system. Similarly, we have positive y-axis and negative axis. So as you can guess, this upper side is called as positive y-axis. Okay, and this below side is called as a negative y-axis. Okay, everything below this origin is negative. So this is called as a negative y-axis. Okay. Okay, so we have understood these basic terms which is related to this system. Now there is one more important term which is related to this system, and it's called quadrants. Four quadrants of Cartesian plane. Okay, so one important term which I forgot to mention is this whole system of two number lines being perpendicular to each other is actually called as a Cartesian plane. So this is a very important term. Let's use a highlighter to highlight it. Cartesian plane. What is a Cartesian plane? It is a system, okay, or an arrangement where these two number lines are perpendicular to each other like this. Okay, x and y axis perpendicular to each other at the origin. Now, yes, so let me draw the Cartesian plane once again very quickly. So we have something like this, okay, and then we have something like this. Yes. Now, this Cartesian plane, okay, is divided into four quadrants. Okay, is divided into four quadrants by these two number lines. Okay, so I'm just going to put the numbers. This is called as first quadrant, or like this. Okay, quadrant number first. This is called as quadrant second. So quadrant second. This is called as quadrant third. So you can see the rotation is anti-clockwise. It's not clockwise, it's anti-clockwise. We start from this one, both are positive, this one, then this is positive, this is negative. Then quadrant 3, this is negative, this is negative. Quadrant 4, this is positive, this is negative. Okay, so I'm going to write here quadrant 4. Quadrant 4. Okay, so once again, let us name these lines. We forgot to name. So this is x dash and x, it's called x-axis, and this is y and y dash, it's called y-axis. So these two number lines x and y have divided our plane into four quadrants. It's called 1, 2, 3, 4. Okay. So this is our basic introduction to the Cartesian plane. Now the last point which is remaining in this Cartesian plane is finding coordinates of the points on a Cartesian plane. Okay, so how do we find the coordinates on a Cartesian plane? So this is going to be similar to this exercise. Okay, here we had a number line, right? And on number line we were putting different points and trying to find the distance from the origin. We are going to do the exact same thing here. We are going to have different points on the Cartesian plane and we'll try to find their coordinates. Now to do that, first let's get rid of this. Okay, so we already have one Cartesian plane here ready. Okay, so just to have an overview, this is our x bar x-axis, this is y bar y-axis, and these are our numbers. Okay, so as we know before, this is one number line and this is another number line perpendicular to each other from the origin 0. Okay, now we want to find the coordinates of every point on the plane. So for example, let's take a point. So I'm going to take this point here. Okay, let's call this point as P. Now, how do we refer to P, or how do we locate the address of a P? So what we do is we first find the perpendicular distance of P from the y-axis. Okay, this is our point P, this is our y-axis. We find the perpendicular distance of point P from the y-axis. What is that? So it will be equal to 3. Okay, so I'm going to write this in bracket like this, 3 comma. Next, we find the perpendicular distance of P from the x-axis. So this will come down like this, x-axis. So what is this? What will be the value of this perpendicular distance from the x-axis? It will be equal to 2. Okay, so I'm going to write here 2. And thus we say coordinates of P is 3 and 2. Okay, so what is 3? It is perpendicular distance from y-axis. What is 2? It is perpendicular distance from x-axis. Now, the terminology is, this is called as the x coordinate. Okay, this is called as the x coordinate, and this is called as the y coordinate for a given point. Okay, so what is the x coordinate of P? It's 3. And what's the y coordinate of P? It's 2. Okay, that's it. This is how we plot, or this is how we name the different coordinates in the different coordinates of different points on the Cartesian plane. Now, just for the sake of exercise, let's take one more point. Let's take this point here. Okay, let's call it Q. Now, I want to find the coordinates of Q. I want to find the x coordinate and I want to find the y coordinate. So first, I'll just give it like this. Okay, first let's find the x coordinate. What is the x coordinate? It is perpendicular distance from the y-axis. It's opposite. For x coordinate, we find the perpendicular distance from y-axis. For y coordinate, we find the perpendicular distance from the x-axis. It's opposite. It's never, x coordinate is never a perpendicular distance from x-axis. No. x coordinate will be the perpendicular distance from the y-axis. So let's draw a perpendicular. Okay, what will be this value? Okay, this value will be equal to 2. So 2 becomes my x coordinate. Now, next we want to find out the y coordinate. So I'm just going to mark here y coordinate. What is y coordinate? It will be perpendicular distance from the x axis, correct? So once again draw like this, perpendicular distance from the x axis. Now what will be this distance? This distance will be equal to this one, this number here, minus 3. So I'm going to write here minus 3. Again, what does the negative sign indicate? The negative sign indicates that it is the lower half of the y-axis. So 2, 2 comma minus 3 are the coordinates of this point Q. So in this fashion, you can put any point, okay, any point on this whole Cartesian plane, and we can uniquely determine the value of that point using this x and y coordinate systems. Okay. Now, just to quickly make a note of the definitions of x coordinate and y coordinate. Let's remove this. So all right. So here is what is the definition of x coordinate. We have already seen this. So x coordinate of a point, what is it? It is a perpendicular distance from y-axis. Okay, and y coordinate is opposite. So what is y coordinate of a point? It is perpendicular distance from the x-axis. Okay, so these are the definitions of x coordinate and y coordinates of points on this Cartesian plane. Note that P3, 2 will be very different from P2, 3. So in fact, let's do that as a part of exercise. Let's say there is another point. So I'm going to write here plot. Okay, plot x2, 3 on the Cartesian plane. Okay, so this is our Cartesian plane, and let's plot this point. Okay, this point x2, 3. Okay, so what is 2? 2 is the x coordinate. What is the definition of x coordinate? Here it is. Yes, 2 is the x coordinate. What is x coordinate of a point? It is perpendicular distance from y axis. So this is my y axis, and perpendicular distance from y axis has to be 2. So let's use another color. Okay, I'll use red. So perpendicular, and it is yes, most important, and it is positive. So since it's positive, it will be in this plane. Okay, so perpendicular distance will be 2 from the from the y-axis. Yes, so this, you can see this line here, this line. In fact, let's draw a line itself. So this line has a perpendicular distance of y, perpendicular distance of 2, perpendicular distance 2 from the y-axis. Okay, take any point on this red line, it has a perpendicular distance of 2 from the y-axis. Okay, now y coordinate is 3. What does 3 mean? Y coordinate of a point, which is perpendicular distance from the x-axis. So from the x-axis, I need a perpendicular distance of 3. Okay, so once again, I'm going to draw a red line, and this is that red line which will have a perpendicular distance of 3, okay, from the x-axis. Okay, you take any, see, it is perpendicular distance of 3 from the x-axis. Okay, and now both these points have intersected at this point. Okay, both these lines, sorry, have intersected at this point. So this is my point x, which is 2, 3. Okay, so it is 2, 3. This is my point x. This one is my point x. So as you can see, it is 2 from the y-axis, and it is a distance of 3 from the x-axis. So 2, 3. So this is how we use a coordinate system. Very simple, just two perpendiculars over each other, but very effective in exactly determining the positions of different points using this x coordinate, y coordinate system.